Good morning all, it's Postbag. Right, this one first. It just says lamp light. Let's see what a lamp light is. Oh, I think it's a lamp controller. Yes, I think this is another of these WS2811 or WS2812 Neopixel controllers because it has the red, white and green wires coming out. It has black and red going in. Now it says here DC 5 to 24 volts in. There are 3 buttons here. Where are they? Are they on the back? No, I think they're on the front. Oh, are they touch switches? Because they don't click. That's interesting. And it's called an SP002E. Gonna have to look at this one on eBay now. Shall I do camera pointing at monitor or screen capture? Maybe I'll play with screen capture again. My server fell over. It's just rebooting. It'll probably go beep in a minute. Okay, so yeah, this is a WS2812 or WS2811, 5 volts or 12 volts. Now, interestingly, they've got here a selection box, 5 volts or 12 volts, even though the unit on it said that it will work from 5 to 24, but not sure why that is exactly. Canadian $3.49, that's $2.60 US. Canadian 59 cents of shipping, and this came from Eddie Store 2008. Description, this is interesting. 76 dynamic modes, so 76 patterns we assume. 6 level speeds, but it will control 2048 pixels in a string. So I assume what it means by that is that for each frame, I suppose it puts out 2048 codes. So that's quite interesting. Easy change mode, speed, color by pressing 3 keys on its ultra slim body, auto memorize function. The picture on the eBay listing doesn't quite tie up with this one. They've got 5 volt version and a 12 volt version. This, as I said 5 to 24 volts. Where is that? Oh yeah, down this bottom end, 5 to 24. Can't focus on that. This one also has mode plus, mode minus and speed, whereas these have mode, speed and auto, so slightly different. I'm really curious about what's under here and how these buttons work. So I'm really tempted to take the covering off this. I think I might do that. Oh, well, what an idiot. I should have realised those 3 lumpy things in there are actually just ordinary push button switches, and then there's a microcontroller next to them, so really there's very little point. Yes, those are switches. There's not much point cutting this open. Now that I've worked out that these are not magically touch switches. Okay, I'm going to leave this one up here for the moment because the next one I think is highly relevant. I think it is. Aha. Yeah, that looks pretty good. Okay. Well, here you can probably see that we've got rings of these Neopixels. I think these are 16 pixel rings and this is a 24 pixel ring, and there are connection points on the back where I could solder these on, so I think I might do that. But just before I come to those, we'll have a look at this one. This is a Qeasy power bank charger doctor. Let's get that out of its bag. Okay, just a quick look at the spec. It's a USB tester. Input voltage 3 to 9 volts, plus or minus 1%. Current, well, plus or minus 1% is the accuracy, I presume. And current 0 to 3 amps, again, plus or minus 1%. This is it. I can't quite remember why I bought it. I got a feeling it's because it has 2 displays and they're different colours or something. It also has 2 USB outputs. Anyway, we want to see this fired up, don't we? Okay, my mistake. Both the displays are the same colour. Okay, so it's reading 5.1 volts. The power bank saying it's 5.0. Actually, I've got a feeling that if I press this up, now if I press that, this goes up to 5.5 volts. Okay, that's responded. 5.42. Is that my camera making that look really wide? No, it's got quite a fat wide aspect ratio, that display, which is quite nice. 5.42 volts, no amps. Right, let's just try this with a variable USB DC load. It's a 7-port hub with some lights in it. Let's start switching them on. Okay, so 40 or 50 milliamps, 100 milliamps, 150, 200 presumably, 250, 300, 350 milliamps. It's reading 320. Now, did the voltage drop at all during that? Is there an overall on-off switch? I don't think there is. No, the voltage is holding up pretty well. One thing you'll notice about this power bank... Oh, focus! Yeah, one thing you'll notice about this power bank is that at the moment it's showing the voltage. If you put some load on it, it switches over to showing the percentage charge left. So it's saying 95%. These indicators here don't actually do anything, which is unfortunate. Anyway, I'm talking about this power bank. I'm supposed to be talking about this charger doctor, but what is there to say? It's a 2-display charger doctor with 2 outputs. Wonderful. Let's talk about the power bank. Yes, this is my favourite power bank. I do get asked a lot about this. The reason it's my favourite is because it's got this variable voltage. If I hit that again, it will go up to 6 volts, and it will go all the way up to 13, or is it 13 and a half? I can't quite remember. 2 USBs and this variable voltage output. If you go beyond 5.5 volts, the 2 USBs shut off, of course, because you don't want more than 5.5 volts coming out of there. Let's have a quick look inside. A bit impromptu this, because it's supposed to be Postbag, but I get so many questions about this. I'll also show the things on the back in a moment. Okay, yeah, so that's it. I've got 4 18650s in there, all in parallel. There are the electronics, the display, the inductor for the boost converter, and the socketry. Okay, let's just put that back on so that I can show the back. So this is a QD184SX. It's Qidian, Qidian, and that's the model number. Can't find them on eBay at the moment, but I know someone put a link to one on AliExpress recently, so they are available. So this item is a USB charger doctor current voltage charging detector battery voltmeter ammeter. It's just $2.20, free shipping, and this came from Alice110 1983. Now let's have a look at one of these Neopixel rings. This is the 24 Neopixels, WS2812 chips, all in a circle on this board. Now on here, let's get in a little bit closer. Right, we have in VCC and ground, and we have out VCC and ground running back the other way. So if I connect the 3 wires from that controller to in VCC and ground and make sure it only gets 5 volts, should be able to fire this thing up. Right, just warming up the soldering iron. Now I'm just going to cut this plug off because it doesn't mate with anything. The string of WS2811 LEDs I bought the other day has a 2-pin, and this is a 3-pin, and they were upside down anyway with respect to each other. So that's coming off, and I'm going to just tin those ends and actually solder them onto these pads. Right, so I want the ground, VCC and in connections. Let's tin these. Right, in is green. They don't quite line up. Then it's VCC, so that's going to have to jump across. VCC. And ground is on white. I assume it's on white. Okay, in VCC and ground. Right, I better just check what this is set to, because I might have left it to automatically come on when you power up. No, I didn't, but I have set it to 24 volts, so that's got to come down. Just 5 volts for this. Now I'm just setting a current limit, but thinking about it, that might draw quite a bit of current. So what should we say? Let's say an amp. It was set on an amp, and I started to bring it down because... Oh, 1007. Yeah, I'll give it an amp. Right, Load save. Okay, so 5 volts, 1 amp. Right, let's hook up this to the output and then I can switch on the 5 volts. Yes, okay, you want to see it if I get this wrong and make a mistake and it all blows up, so I'll do it on camera. Right, so there it is. Neopixel Ring, power supply on 5 volts. I think I've got all my polarities right. Let's power it up. Oh, yeah, nice. So the default pattern, it would seem, from this device is just cycling through the colors. Let's find a fading pattern. Mode plus and minus are the end switches. Oh, that's nice. Yeah. Oh, that's good too. Well, perhaps the rest of this video can be me cycling through 3 of those. Oh no, more of those because it's going through all 8 colours. Me cycling through the 76 modes and getting all excited about pretty patterns and pretty colours. Come on, where's some fading modes? I'm bored with... Oh, I'm bored with... Oh yeah, that's blue, yellow, pink. I'm bored with these stepping modes. I want fading modes. That's interesting, that. It's almost as though it were designed for a circular... It's almost though it were designed for a circular ring of 24 LEDs. How does that controller know that I've got a circular ring of 24 LEDs? Because that's absolutely rotating perfectly round a 24 string. That's just bizarre. I don't understand that. Actually, some of them weren't, were they? Some of them, they did look a bit... but most of these seem to be designed for a 24 pixel. Do you know, there's only one way to be absolutely certain about this. Let's find a nice one. Yeah, sort of blue and red. And attach this to one of these 16 ring. Is this me? Yeah, I'm going to attach it to one of these 16 LED rings because I can't quite believe that. Now, thinking about this, it would be the same, but there would be a discontinuity because it would be driving 16. Then there'd be a small gap while it drove the remaining 8. So there'd be a bit of a jump. So I'm going to leave it on that pattern. This is actually getting quite warm. Oh, now, wait a minute, if I turn that... Oh no, it said it memorises the last pattern, doesn't it? So it won't jump back to pattern number 1. It's just not quite the pattern I wanted. Green and red. I want something that's... Oh yeah, that's quite good. That's obviously rotating. Okay, 16 LED ring it is. Right, so hook this up to this one. It's a bit awkward because green is in the middle on the cable, but not in the middle. Yeah, that's it. In VCC ground. So VCC. Can't see what I'm doing. Ground. Right, let's try that one. Okay. Well, I can't see a jump. I must be thinking this wrong. I don't understand how that can be rotating perfectly on a what's this, 16 pixel ring, and also rotating perfectly on a 24 pixel ring. Is that one of these bizarre mathematical mental puzzle things which I just haven't quite got my head around? Let me pick a pattern that's a bit more on and offy, not quite so fadey. Ah, maybe this one shows it. There's clearly a discontinuity there. How many green dots are there? There seem to sometimes be 2 and sometimes 3. Is that background colour gradually changing as well? I think it might be. Yeah, I think I can now see the discontinuity. So I'm going to leave it on that pattern and put it back on the 24 pixel ring and see if this 2 and 3 LED discontinuity goes away. I have to say, I'm just loving this. The fun you can have with a couple of dollars worth of cheap electronics. It's absolutely brilliant. Oh, well, there's a discontinuity there as well, isn't there? Because sometimes that looks like there are 3 dots and sometimes it looks like there are 4. So yes, the pattern may not be based on a 16 pixel repeat or a 24 pixel repeat. I have no idea how many pixels the repeat on this is. Oh, I think I've blown my mind. Right, well, they were fun, weren't they? Yeah, 2 pieces RGB LED ring 16-bit WS2812 5050. That's the size, I think they're 5mm square. Oh, the package may be called a 5050. I think it is actually. RGB LED plus integrated drivers, which is the WS2812, for Arduino, $5.58. Free shipping, Alice 110 1983. And this one is 7-bit, 8-bit, 12-bit, 16-bit, 24-bit, 60-bit. Now this is actually the 24-bit unit, or 24 LEDs it is. WS2812 5050 RGB lamp panel round LED. So I bought the 24 bit, $5.20 free shipping. Alice again. Let's just have a look at this 60-bit. Okay, that one comes in 4 segments, which you presumably have to attach together in some way. I'm not quite sure how you would do that. But yeah, I bought the 24-bit. Only get one of these for $5.20. Right, this one next. Absolutely no idea what this is. There are no clues. I mean, I do like to sometimes know what I'm looking at before I open it, in case I get a shock. Oh, it's the replacement PIC programming board or demo board with the, what's that? That's the JST connector on it. Right, not much to say about this because we have seen this before, but I wanted to get another one because on the other one I took the JST connector off and replaced it with a sort of male pin header. The spacing is 0.1 inch, but I couldn't quite get my programmer down onto these pins. That's quite a handy cable, isn't it? USB to 2.1mm. The only thing we will have to do with this board is just cut the track right up in this corner. This track here running down from the VPP pin, because it merges in with the clock components, the resistor, capacitor. Now, are they the clock components? No, they're not the clock components. Can't quite remember what they are, but there's a complication. No, they're the reset resistor and capacitor, that's right. Because VPP goes down to this pin on the corner of the chip, which is both the programming voltage and reset, and they don't harmonize well together. So the mod I made was to cut that track there and run the VPP pin, which would be that last pin, down to the inside pin on that jumper. So at the moment it runs down, mixes in with the reset components and goes to the outside pin on this jumper. I modded it so that this connected to the inside pin, so that by removing that jumper, that one bottom right there, it actually separated the programming voltage from the reset components, and that seemed to solve the problem I was having. Now also, of course, the thing I wanted to say is that this is for my PIC programming tutorials, which I'm very keen to do, but I want the culmination of that to be that we use the PIC to send out a bit stream suitable or suitably fast for driving these things. So that's why I've got these things in, the 24 LED one and the 16 LED ones, because I want to try and write simple loops of code that can get these to do really the basics, light up in different colors, and then drive more than one, because we need to then drive subsequent LEDs. It probably will be a lot of coding to get nice swirly patterns and rotating stuff. But that's where I want to go, because I want something visual. I want something you can see. Right, well, we've seen this before, but I think I've managed to find a cheaper one this time. So this is One Piece's new 5-volt PIC 12F675. That's the chip. Development board, learning board, breadboard. This one is $6.99, free shipping, and this one came from Lovecell 2013. Right, let's do one more. Again, no idea what this is. I can't find any identifying features, but it's very flat. Ah, it's a little module. Oh, well that's ages old. Well, this is a TP4056 lithium single cell charger board, up to 1 amp the TP4056 can go. I think I bought this when I was buying stuff for 99 cents, because I think you can get these for 99 cents or maybe even cheaper. I doubt I've got this on my purchase history, or at least it'll be there, but it probably isn't a live listing. Maybe it'd be more interesting to see just how cheap these things are. Let's have a quick look at the board again. So this board has the TP4056 on it. Yeah, that's a better view. So you can see that on the left next to the USB socket. It also has, top right, a DW01 cell protection IC. So that stops the cell connected to B plus and B minus going over voltage. No, it doesn't really, because the TP4056 stops the cell going over voltage. That tops out at 4.2 volts. But certainly that DW01 stops the cell going under voltage. If you draw current from these out pins, why is this all distorted? That's it. Then the DW01 stops you drawing current when the battery voltage gets below about 3 volts, I think it is. We could check that on the DW01 datasheet. It's the 8205 MOSFET, a dual MOSFET, the one down bottom right here, which actually shuts the circuit, or opens the circuit, I suppose it is. It disconnects the battery from your output connections if the cell does go under voltage. The DW01 does other things. I mean, it does do over voltage protection, but of course it's not needed here because the TP4056 would never take the cell over voltage. So yeah, I mean, this is a really handy little board, and they are incredibly cheap. Right, okay, these are incredibly cheap. I hadn't realised quite how cheap these had got, but this is the board with the 3 components on it. So it's the same board, and this is 10 pieces of this board. 1 amp, 18650, yeah, okay, TP4056, but it also has this DW01 and the 8205 MOSFET. $3.68 for 10. That makes them 36 cents each. Free shipping. This one's from Chip World. And so these are today's Postbag items. Don't go away though, because it's time for the end card segment, where I'm going to build this robot kit. So if you enjoyed this video, there are a couple more videos up here which may interest you. If you want to subscribe to this channel, well, just touch my face. And down here is the link to Patreon. Now, if you want to become a Patreon donator, that's the link to use. And all the money from Patreon goes via PayPal to my eBay purchases. So it's just used for buying items for Postbags primarily. And if you liked this video or disliked it, the buttons are down here under the screen. Cheerio.